All right, in this problem, we're going to talk about how do you rewrite a step function of some kind or a piecewise function in terms of Heaviside functions or a combination of, say, constants and Heaviside functions. I'm using constants here just because each of the pieces of my piecewise function is constant. You'll see how that works. But you could kind of do the same argument even if you had something like, x squareds or t squareds. Oops, I already see one typo here. So this x, of course, it should be a t. So it's going to change back in a minute. But what have we got? It's 4 if t is less than 0. It's negative 3 is if t is between 0 and 2. And it's 5 if t is bigger than 0. So over here on the right, I've got Desmos pulled up just to look at. Okay, so what we want to do is try to model this piecewise function in terms of some Heaviside functions and some constants. So what I've highlighted in blue over to the left are, what are the places where the formula changes for your piecewise function. So it looks like t equals 0 and t equals 2 are important. So that tells me we're going to use two Heaviside functions. We'll use the following two. Use 0, which is the Heaviside function that is 0 if t is to the left of 0, and 1 if t is to the right of 0. And so on Desmos here, I'm going to use this one. So that's use 0, this blue. And the other one is what happened, and also notice, just to remind you, right, that's kind of supposed to model like, okay, a switch turns on at t equals 0, and it's like one constant unit of power as time goes on. Now the other one that I'm going to use is where the switch also turns on at 2 seconds, say, if you want to think of it that way. So u2. So it's just the step function where the step happens at t equals 2. Now what I want to do again is I want to use both of these, so this one and u0, in order to try to model these steps. So how can I do that? Well, one thing that you might notice is if I compare, say, the red line to the left to like the blue on the left, right? You might notice that, the red actually looks like it turns from it turns from on to off at t equals 0, whereas the blue looks like it turns off to on at t equals 0. So one goes on to off, and the blue goes off to on. So like, how do I make that switch in a formula? And so just to show you here, what if you just took your formula for u0 and just subtracted it from 1? So just to show you this little trick in general, let me scoot over here. If you take 1 minus uc of t, remember we're just saying the switch happens at c, where c can be anything. We just care about when c is 0 and 2. I'm saying this is a trick that works more generally. When you take 1 minus that though, that switches, that flips around what's going on. So in other words, now we turn from on to off when we pass over that important point C. Of course, I see another typo. There should be a C right there and right there. So again, it's 1 minus UC is sort of like the reverse of UC. I hope that that makes some kind of sense. So what are we going to do? We're going to try to use that in order to model at least the left part of the red function. So what we might do is I definitely need to take, say, 1 minus u0. And so if I did that, then I have, and let me get rid of some of this here. And just to show you in the picture too in Desmos, right? Here's u0, it's blue. When I take 1 minus that, it's black. And just notice that, the steps change, right? So what else do I need to do though? It's like, all right, I want this to model the red. And so on the left side anyway, I just want to get this up to, it needs to get up to 4. It's at 1 right now, so think college algebra. I'll just multiply by 4. So the function we're going to look at is not just g, we're going to look at 4 times g. And now just what I want you to notice, when I do that, the red on the left, it's modeled by 4 times g. So that'll be part of my answer that's going on here. So just to write down some of the algebra, here, how do I model the first part? We should use 4 times 1 minus u0 of t. And that is the step function that is 4 if t is less than 0, and 0 if t is greater than or equal to 0. Also too, just like you kind of trust your instincts, right? You really are just going to multiply this by 4 and this by 4. So that gives you 4 and 0. So that's all we're really doing. It's just taking that 4 and multiplying it through. All right, cool. So then what we need to do is model what's the next part. So the next part would be, well, this little piece of the red graph on the bottom. And it looks like the y value for the little piece on the bottom is negative 3. So we're looking at the yellow over on the left, that portion here. And, well, that looks like it's got something to do with the switch going on or off, say, at t equals 0. We could think of it that way. And so what I'm going to do is I'm going to think of this as, what if I just took this part, u0 again, and what if I just multiplied it by -3? If I multiply it by -3, well then the switch is down there now, right? So hope that that makes sense. If I take u0, right, it's going the right way. I'll just multiply it by -3, and then now I get the switch, the green part on the bottom there that matches the red. All right, cool. But there's something that is a little bit off, like we're not quite done yet. We've only modeled the two parts of it here. But so far, like, where are we at? I'm going to take the green piece for 1 minus u0 plus -3 times u0. And like, what would that be? You can really just kind of line up. Like, okay, when t is less than 0, 4 plus 0, it should be 4. And then also, when t is bigger than or equal to 0, we're going to do 0 plus -3, which is -3. And so we've modeled part of what's going on. And if I do that here, this is what I've got as y3. I've got this much in my picture. But what do I need to do? Well, at t equals 2, it needs to jump from the purple up to the red somehow. And so this is where we're going to use the step function u2, or the Heaviside function u2. But what we need to be careful about is like, well, how do I make that jump? And it's really tempting to just say, I should just do 5 u2 because, well, it needs to get up to 5, right? But it needs to get up to 5 from -3. So it's not just going to be 5 u2. So just to show you, right, with the algebra, why it's not 5 u2. 5 u2 would have, you know, the higher step being at 5. But if I just take this and add it to these guys, that doesn't get me up to, that doesn't get this piece up to 5. It only gets it up to 2, right? Because when I take this and I add it to this, whenever t is to the right of 2, that doesn't take you to 5. That takes you to 2. So that's not good. So again, you can kind of see in the picture though, what do you need to really multiply by and add on to it? You really need to multiply it by 8 to get from -3 up to 5. So that's the trick. So instead of using 5 u2, you should use 8 u2. And so now if you add all three of these functions together, you recover your original function. And so just to show you that here, I am just trying on Desmos here to highlight the original function here is in red, right? And on the bottom is the three functions that I have over in green plus yellow plus pink on the left. And when I do that, just notice that it captures that completely, right? So it's the exact same graph.